Okay, let's look at this next one here. It says, what is the function right here approaching as x approaches infinity? In other words, what's the limit as x approaches infinity for this function right here? Anytime the independent variable, in this case x, is approaching infinity, and you're looking at the limit of that, then you're talking about a horizontal asymptote. How do you find horizontal asymptotes? Look at the powers. Look at the degree. The degree of the top is to the fourth power. The degree of the denominator is to the fifth power. Referring back to the early part of section 2.4, if the degree of the denominator is bigger than the degree of the numerator, then it has a horizontal asymptote at y equals 0. So that means that this thing does have a horizontal asymptote, and the height or the y values are approaching 0, flatlining, getting very close to the x-axis in the long run on both the left and right hand side. So the horizontal asymptote is at 0. Degree of the bottom is bigger than the degree of the top. Anytime you do a ratio of the powers, here's another way to remember this. Most people remember that if there's a tie, you look at the leading coefficient. But this is not a tie here in powers. The bottom is bigger. If that happens, like if you just look at the powers, 4 over 5. If your number on your powers is less than 1, 4/5. Okay, looking at the ratio of your powers, 4/5. If that ratio is less than 1, then it's going to have a horizontal asymptote at 0. If that ratio is bigger than 1, let's say you had 5/4, then it's not going to have a horizontal asymptote and it's going to go off to infinity. Like the last video, the ratio of the powers was 3 over 2. That's bigger than 1, so it's going to go off to infinity because there's no horizontal asymptote. And if it's a tie, you look at the leading coefficient. So again, since the bottom is bigger, or the ratio of the powers is less than 1, then it's going to go to 0. Okay, what are the x-intercepts and vertical asymptotes? X-intercepts from the top. Set the top equal to 0. Set 2x minus 3 equals 0. Add 3 and divide by 2. 3 halves or 1.5. Vertical asymptotes. Set the denominator equals 0. Add 5 and divide by 3. 5/3 or about 1.67 is where there's a vertical asymptote. Okay, now make sure these are different. If these are the same, then no, that wouldn't be the case. Something would cancel out. We'll get to those in a little bit. But those are the answers for the x-intercepts. Now, to sketch the graph for it, mark those things down, that there's an x-intercept of 1.5 and a vertical asymptote of 1.67, and also that it flatlines at 0. So we know on the far left it's going to flatline, and on the far right it's going to flatline. But we don't know if it flatlines above this spot or below this spot, so you got to plot a point to the left of everything. So to the left of everything, I mean to the left of these two spots right here. So an easy point to plug in to the left of 1.5 is 0. So I'll plug 0 in to see what we get. And if I put 0 in, I don't know if I did this here. Let's see. Well, let's talk it through. If I put 0 in there, what do you get? Well, 2 times 0 is 0. 0 minus 3 is negative 3, and negative 3 to the fourth is positive. So on the top I get a positive. If I put 0 in here, 3 times 0 is 0. 0 minus 5 is negative 5. A negative to a fifth power is a negative. So I end up with a positive from the top over a negative on the bottom, and a positive over a negative is a negative, and that's how I know that it's flatlining below. So somehow it flatlines here, and somehow it has to get over to here. So typically these things will dip down a little bit here to go from here to here. It doesn't like flatline the whole way across. So it hits this spot. It really doesn't matter about here. Now it hits this spot, and you check out the power of that spot. Well, 1.5 came from the top, which is to the fourth power, and evens bounce. Hits that and bounces down this vertical asymptote. Check out the vertical asymptote. That came from the bottom, fifth power, so it doesn't bounce. It isn't an upside down volcano look. It starts on the opposite side then. So it comes down and it has to flatline because there's a horizontal asymptote. And that's the graph of this thing. Then you can answer questions like, what's the limit as x approaches 5/3? Well, that's this point right, this vertical asymptote. And it's not going to exist. The reason why this limit doesn't exist is not because there's a vertical asymptote, but because both sides of the vertical asymptote doesn't go to the same direction. This side is going towards negative infinity, and this side is going to positive infinity, so that limit does not exist. Okay. Now, if you look at one-sided limits, like for example, what would be the limit as x approaches 5/3, and with that little negative, that means on the left-hand side, that's heading towards negative infinity would be the answer to that. What's the limit as x approaches 5/3, and the positive sign there means on the right-hand side. Well, on the right-hand side of that, it's going to positive infinity, and that would be it. Well, let's go ahead and look at the third one here. For this function here, what's this function approaching as x approaches infinity? Horizontal asymptote question. Okay, so let's look at the powers. Fourth power, fourth power. It's a tie on the degrees. When it's a tie on degrees, you look at the leading coefficient. The leading coefficient here is not 2. The leading coefficient will be 16 because it's 2 to the fourth. So it's 16 over 3 to the fourth, which is 81. So the answer to that problem is 1681st. That's what's going to flatline to, that height of 1681st, or 0.1975. Again, you only do that leading coefficient stuff if you're looking for a horizontal asymptote and they're both to the same power. They are. So look at the leading coefficient. A lot of people get this wrong and say it's 2 over 3. It isn't. It's 2 to the fourth over 3 to the fourth. Okay, so that's the horizontal asymptote. That's probably the hardest part of this. The x-intercept is at 3/2. Boom, right here, 3/2, 1.5, and the vertical asymptote's at 1.67. Those are the same. Also, I have the horizontal asymptote drawn in here at a height of about 0.19 or about 0.2 right there. So you remember it was about 0.1975. I don't even need to plot a point to the left on this one because I know it's got to start off positive because the horizontal asymptote is what it levels off to on the left and right, and that's positive, it's above. So it's flatlining. And then I look at what I'm coming to. The first thing I come to between these two things is the x-intercept. So it goes to this x-intercept. That came from something to the fourth power right here on the top. So it bounces, goes up. This vertical asymptote right here came from the bottom. It's the fourth power, so it also bounces, comes down. It may go through that horizontal asymptote, but it's going to flatline to it on the far left and far right. So we can see that what's going on. The limit as x approaches infinity is leveling off to this height right here at 0.2. And then different things like what's the limit as x approaches this right here, 5/3, would be positive infinity. Yep. So, and then the limit as x approaches infinity, well, that's 1681st. That's what it levels off to. Even though the limit as x approaches negative infinity, it levels off at the same spot, 1681st. Okay, we'll pick up on the next one on the next video.